Everyone, today we'll discuss about another physics experiment for engineering physics course, which is the determination of the rigidity modulus of the material of a wire by dynamical method. That means we have to determine the rigidity modulus of a metallic wire, and the method is the dynamical method. So what is the working formula for that? The rigidity modulus is 8 pi IL by T square r to the power 4 in Newton per meter square in SI unit system. So before going through in details about this parameter, so let's take a first look about the instrumental setup. So here you can observe this is the total instrumental setup. So I will take a close look of this instrument. So if I move the camera, you can observe here there is a wire, which is a metallic wire, which is suspended from at that point, and it is connected to a heavy metallic cylinder at that point, right? And this is the cylinder, and if you observe carefully, you will find that the cylinder is suspended, or it is located over a angular scale. So this is a very simple setup to find out the rigidity modulus. So now let's take back again with our working formula to understand the parameters. So here you can observe clearly that the parameters are 8 pi IL T square r to the power 4. This I is the moment of inertia of the cylinder. So whatever we have just observed, the metallic cylinder at the bottom of our instrument, this is the moment of inertia of that cylinder, and we know that the moment of inertia of that cylinder is equal to half m r square, where m is the mass of the cylinder and r is the radius of the cylinder. The next parameter is small l. Small l is nothing but the length of the wire, okay, the total length of the wire. And then small r to the power 4. What is the small r? Small r is the radius of the wire, okay. So if I draw here, you will find that a wire is connected at the bottom with a cylinder. So this is the length of the wire, and capital R is the radius of that cylinder, and you have to measure also the radius of that wire, which is the small r. Okay, clear? And what is the T? T, when we just make a twist of this cylinder, I will show you in details later on. If I make a twist of this wire by rotating with a small angle of this cylinder, it will oscillate, okay. So this T is the period of oscillation, we have to take that one, right? And if we measure all this parameter, we can find out the rigidity modulus of the wire. So what you have to do first? You have to first measure the radius of the wire, that means this wire, and you have to measure the radius of this cylinder to find out the moment of inertia of that one. So how can you measure the radius of that wire? For that, as you know, this is a very thin wire. So to measure the radius, you have to first measure the diameter of that wire, and if you take the half of the diameter, which is the radius. So how to take the diameter? For that, you all know we have to use the screw gauge instrument, right? And I believe that you all know. So let focus it first. I believe that you all know how to use this screw gauge. So first you have to open the screw gauge. So I will show you here. So first you have to place your screw gauge, and in between the screw you have to place your wire properly, and you have to tight carefully here, and from there is a linear scale and there is a circular scale. You all know how to use that one. There is a least count. Using the proper method of screw gauge measurement, you can find out the radius of the wire. And for this experiment, you have to take at least the measurement for 3 different positions. You can take at the top, at the middle, and at the bottom of the wire. And let's look about its table for radius measurement. So here you can easily find out what is the table for the screw gauge. First you have to take the linear scale reading. So from here, I believe that you all know how to use this screw gauge. If you forget or if you don't know, please go through our previous video. So you have to take the linear scale reading, circular scale reading. You have to find out first the least count of the screw gauge, and then you will find the diameter actually. So this is the diameter, and from the diameter you have to find out the radius of the wire. You have to take the mean for 3 different position, and then you have to write down the corrected radius. That means first you have to find out is there any zero error or not with this instrument. If there is an error either positive or negative, you have to subtract or add accordingly. So from that table you will get, or you will be able to calculate the radius of the wire. Next you have to find out the diameter of the cylinder. Basically you need the radius of the cylinder, and if you find out the diameter, then you easily find out the radius. So for that you have to use this side calipers instrument, because I can show you here. So by using this slide calipers you can easily find out the diameter of that one, right? So if you type here, from that there is a main scale reading, vernier scale reading, and the vernier constant, you will be able to find out the diameter of the cylinder, right? So for that you have to make another table which is shown here, and for that also you have to take at least 3 different diameter. That means the diameter at 3 different position, main scale reading of the slide calipers, vernier reading, and you must know how to calculate the vernier constant. Then you can find out the total diameter. Then from there you will find the mean diameter, and from there you have to find out the mean radius also, and you will get the radius of the cylinder. So third part, according to your formula which is written here, so we have measured the radius. That means we can find out the I if we know the m. M will be provided to you. It will be almost 2.5 kg to 3 kg, and you have measured this small r, that is the radius of the wire, and you have measured the L by using this meter scale, right? You can just place the meter scale properly, and from that scale you can find out what is the length of your wire, right? So now the last thing what you have to find out, you have to find out the time period of the oscillation, what it means. So at that point you have to make a twist of this cylinder with a small angle. You can find out there is a pointer, you can observe. So if I make a small twisting through an angle, and if I leave it for that one, it will start to oscillate. So you have to count down at least 30 oscillation, okay? That means it will go there, come back, right? This is the one oscillation, go there and the come back. This is the second oscillation, okay? If it starts from here, so it will go there and back. This is the one oscillation and second oscillation, and so on. So at least you have to find out the 30 oscillations, and from your stopwatch you have to record how much time it's taken to oscillate 30 times, okay? So now let's back to the table. So you have to make this table, the determination of the time period of the torsional oscillation of the cylinder. So here the number of observation, you have to repeat this experiment at least 3 to 4 times. So time for 30 oscillation, how much time from your stopwatch you can find how much minute and how much second is taken for 30 oscillation. So then you will take the mean time for the 30 oscillation. So if you divide it by this total time by 30, then you will get what is the time for one oscillation, and which is the time period capital T, okay? So from that you can find out the capital T. So now let's take a look of your working formula. We have the I, that is half m r square, we have the small l, we have r to the r, that means we can find out the r to the 4, and right now we have calculated also the T. So if we put all that experimental values, you can get the calculation, you can calculate the rigidity modulus of the wire in Newton per meter square. But you have to take care that all the parameters should be in the same unit. That means you will find r in millimeter, so you have to change this r in the meter, okay? I half m r square, so capital R will be in centimeter, you have to transform it in meter, small l also in meter, and T in second, and then you can find out it is in Newton per meter square. So this is a very short experiment and very easy experiment you can perform, and after that you will calculate that one. Not only that, in the next part we will discuss how to find out the error of this experiment, okay? So that's all in the first part. Next part we will learn how to find out the error or maximum proportional error. Now we will discuss about the error calculation of our rigidity modulus experiment. This is the working formula 8 pi IL by T square r to the power 4. We can write it in this way: 8 pi IL by T square r to the power 4. In place of capital I, we will write it explicit form half m r square. What is the r? We have seen this r is the radius of the cylinder, right? So let us think about the possible origins of error. So error may come from this term, which is the small l, and we know that the small l is the length of the wire, and we have measured this length using the meter scale. So from that instrument error may occur. Error may also come from this T square term, that is the time period, and as we know that the time period is equal to T by 30, that means this is the time taken for the one oscillation. We have seen for 30 oscillation, if you have made the 30 oscillation, then you will write that is capital T is equal to small t by 30. Error also come from this r term. What is this? This r is the radius of the wire, right? So let us write in our formula to find out the maximum percentage error. So delta eta by eta, as we know, this error may come from this L, so we can write delta L by L, and it from this T square term. So here we have written small t because capital T is equal to small t by 30. Okay, so delta T square by T square. Error may come also from this r, so here we have written delta r to the power 4 by r to the power 4, and it also comes from this capital R, so delta r square by r square. Now we know that if we rearrange the term, we will get it is delta L by L, so it is delta T square, so it gives you 2 delta T by T, right? We have also seen how we can get this one in our Young modulus experiment. So delta r to the power 4 by r to the power 4, that means 4 delta r by r, which will be in power, it will be come here, and the rest of the things will be delta r by r. Okay. Now delta r square by r square, so it will be 2 delta r by r. So how we can get the information about the delta L? So what is the delta L? Delta L is the error in length measurement, and we have measured this length using the meter scale. As we know that the smallest division of the meter scale is 0.1 centimeter. So when we are measuring some length, that means it is the difference between 2 points. So the error may come from this end and this end also, right? So the error will be 2 into 0.1 centimeter, because this length is the difference between the two measurement, right? And for each measurement the smallest division is 0.1 centimeter. Now delta T, if we have used this stopwatch where the step of time is 1 second, so the error may come from this smallest time data. So and again when we have started the stopwatch and when we have stopped the stopwatch, we have taken the 2 data. So that is why we have multiplied by 2. So the error may come from the starting point and also in the ending point. So we have to count these 2 sides, right? So now what is the delta R? Delta R, we have measured the length of the wire using the screw gauge. So here this error will be the least count of the screw gauge, and we know that the least count of our screw gauge is 0.001 centimeter. Last error also come from this capital R, that is the radius of the cylinder, and we have measured this cylinder by the vernier caliper. So here error will be the vernier constant, which is 0.01 centimeter. So now we have found out all this term. So if we put that one in this equation, as we know that delta L, you know what is the L, whatever you have measured the length, this will be L, right? If you have taken 2 to 3 times, then this L will be the mean L. What will be the T? This T is the time period this is t is the time to take the 20 or 30 oscillation. This r is your measured radius of the wear, and this capital R is the measured radius of the cylinder. So if you just substitute all the values here, you will get ultimately delta eta by eta, and then if you multiply this delta eta by eta into 100, it gives you the percentage error in eta. So I hope that you have understood how to find out the error in this experiment. So we will again discuss in the next time about the another experiment. So that's all for the day. See you again. Bye.